So awesome to be here and to see so many people online, and I'm excited for the talks that we have ahead. First of all, I just wanted to kind of say we are addressing three goals today, as Kate and Fran mentioned earlier, and quality education is really the first one that we're going to talk about. And I think one thing that I want to kind of read out to everyone is what the global goals for quality education really say, right? So it says ensure inclusive and an equitable quality education and promote lifelong learning opportunities for all. So it's all about inclusivity and equitable education for all. And one thing I wanted to mention before we dive into the solutions, or some of the solutions, is that really interesting and kind of mind-blowing data, actually, that data point that I read today around education. Unfortunately, it seems like COVID-19 has wiped out 20 years of education gains. So I think with this, I just want to say that we have a lot of work to do, and I'm excited to have a lot of speakers today that are really involved in doing great things in the education space around machine learning and tinyML. And with that, I wanted to introduce Robert LEEMAN, Education Solutions Manager from ARM. Robert, the stage is yours.
Thank you very much, Alessandro, and thanks everyone for listening to my talk. So I'm going to spend the time speaking about sort of boiling down what computing education is and what the problem set is. If we just go to the next slide, please. So there is some real problems in computer science education, which are partly systemic, partly technological, and as you can see from the stats there is a real engagement and diversity problem within the STEM cohort. Only 20% of STEM learners are female, and only 35% of learners globally study computing at all, which is a real problem for computing and for STEM more generally. And part of the issue is there is the non-specialist delivery from teachers, and also the methodology in which it is delivered as well, which is typically quite didactic, and some of the practical and creative elements of computer science are often lost and often not realized in the formal curricula. And things like data science and machine learning and artificial intelligence and all these wonderfully modern concepts are only just starting to appear on formal curricula across the world. And so what's my call to action today really, and part of this, the solution to this, to goal 4, is about calling for how can we utilize these tools to modernize computing education and modernize pedagogies in how to deliver that, and how tinyML can be the solution for that is to be part of a tool set on in equipping teachers to be able to deliver effective computing education through practical and physical computing, through things like project-based learning and those sorts of approaches, and using physical artifacts through development boards, through microbits and Arduino boards and Raspberry Pis, and there's a whole ecosystem of these types of technologies that can be used by students and be used to engage students, particularly from those less represented areas, to capture their imagination and let them innovate, let them solve real world tangible problems such as the global goals. And the global goals are a really rich field of context which students can seek to choose to solve using these sorts of technologies, and that can be baked into the way that they formally learn about computer science, and so that it can serve them in terms of formal certification and their learning journey, and hopefully encourage and inspire and engage them to go on and study it in higher education and the like. So what's the impact of that? So really, we want more people and a more diverse makeup of people to be going into STEM education, especially into higher education and into industry. We want to be widening that talent pipeline, and we really want to make sure that we're seeding the groundwork or rather seeding the ecosystem with innovators, with future problem solvers, people that are going to be the next critical thinkers and the next innovators in creating these sorts of products and tools that are going to change the world and solve these problems for the next generation. So the call to action from myself, and I'm sure from everybody else involved in the education world within computer science and computing, is to celebrate the successes that are already here, which we're going to see a lot of throughout the coming lightning talks, to share these projects with your networks and with your own ecosystems, and also invest in developing resources for these, of which we'll see plenty of examples today, but also speak to educators, speak to the wider education community, and try to upskill them and raise their consciousness in what's possible using tools like like tinyML and these development boards to engage their learners and really make them see a future in STEM as something which is not just achievable, not just accessible, but something that they can flourish and thrive in, and try to inspire them to come to see this as an active place to go, and also to invest in developing tools to make that an easier journey, and making machine learning and artificial intelligence and data science more generally is something that's teachable at school. So making tools that are accessible by teachers to train their learners. So, you know, let's work together to solve goal number 4 and create these quality education tools. Thank you very much.
Thank you, Robert. Thank you for that intervention. And moving on, we have the honor to have Jonny Austin, Chief Technology Officer from Microbit Educational Foundation with us.
Thanks very much. So it's really great to go after Rob, who's talked about a call to action, which is making educational kind of technology that can do tinyML. And that's what we are focused on now at the Microbit Educational Foundation. So I'm going to introduce the BBC Microbit, which is a piece of hardware designed specifically for use in classroom to inspire kids around the world. And it was designed as part of a massive collaboration. There are now more than 5 million BBC Microbits distributed around the world being used by students to learn about computing. And in November last year, we released Microbit V2, and one of the absolutely key pieces of why we did Microbit V2 was to give the Microbit enough computing power to run tinyML samples, examples, projects. So Microbit V2 has a Cortex-M4F, 64K of RAM, 512K of flash, and it's also crucially got a whole load of sensors built in on the board, so you've got everything that you need. And in terms of, you know, making something that's really accessible to schools, really accessible to education, Rob talked about, you know, making sure that things work. There's teacher training, there's resources, and we focused a lot on that in Microbit. So the device itself is really easy to program. You've got drag and drop blocks or MicroPython. You've got simple wireless communication. You can communicate with other devices. It's battery powered, so you can take it with you. You can plug it into things. You've got built-in motion sensors, and there's already an ecosystem of hundreds of sensors and accessories that work with the Microbit. So if you move to the next slide. With Microbit V2 then, and all of those accessories, we started to look early on at what could we do with the Microbit and machine learning. And we've got 2 nice examples at the moment. I'm going to put the GitHub link to one of them in the chat. And the first one is about making the Microbit behave like a smart speaker, so recognizing its own name, so recognizing the Microbit word. And the other one is about recognizing dance moves, so really interactive for kids. Now, the reason the foundation exists is to inspire every child to create their best digital future. And this is a super important project, a super important statement for us, not just because it gets us all inspiration every day, but it's about the fact we're trying to say we don't know what the digital future holds. We don't know what students are going to do and what the world is going to be like, but we want to empower students to have a mastery of technology in order to guide that future. And what we found on the next slide is that if we give those students authentic problems, real challenges that they have to solve, and accessible and effective technology, things where their first experience of technology is success, not failure. And actually, if you give that to students who don't really know what they shouldn't be able to do, then what you get are some absolutely incredible solutions that are kind of inspiring and powerful and really address these global goals. So if we take an example of where we've done this, there's the Do Your Bit challenge, which we run every year. And the goal is we set students these, some of the global goals. We set them 5 of them this year. So 3, 10, 13, 14, and 15. So just to give you a bit more detail, they kind of, those students look at those goals. That's, I think, health and well-being, equality, life on, so climate action, life below water, and life on land. And they're using the Microbit to tackle those goals. So we had some incredible solutions from the students last year. We got some pictures here, and I'm going to share the link to those winners in the chat as well. So if you want to check out these winners, just if we go on to the next slide and highlight a few of those, we've got some absolutely lovely projects. We got one which was about pulling birds' nests out of rising rivers when the river level rise. We've got a project here about tracking trees, noticing their motion. We've got a bunch of kids that looked at asthma in their community. So the bottom right, they were looking at asthma and they knew that at high temperature, asthma was more prevalent. And so they made a device that warned students like when to stay inside because they might be at greater risk. So those are some really lovely projects. If we go to the next slide, have identified across all of our work in Microbit that absolutely essential to the effectiveness of Microbit in empowering kids to do these incredible things with technology is making sure they have a completely seamless, smooth, effective experience. And we've done that really well on computing education so far. And we're just at the point where we're tackling that with tinyML. We're working out how can we provide that completely smooth, empowering experience for kids with tinyML. And, you know, putting this in the context of tinyML for good, then on the next slide, we've kind of said today the Microbit can target some of these global goals. And what I thought was a brilliant point made in the keynotes was that by adding tinyML to the things we're doing, we can tackle even more of the important sustainable development goals. And actually, our contention is maybe with, you know, empowered students, creative minds, the right hardware, we can tackle all of these in some way using something like the Microbit. So the call to action here is come and join us at the Microbit Foundation in trying to work out how we solve the problem of empowering kids to do tinyML, empowering them to solve these problems. Thanks very much.
Awesome. Thank you so much, Jonny. Very inspiring and so cool to see so many good projects already happening on Microbit. Cool. So the next speaker is Marco ZENNARO, research scientist at the Abdus Salam International Center for Theoretical Physics. Welcome, Marco.
Thank you very much, Alessandro. Thank you very much for having me here. And I think those are Vijay slides. Okay, there you go. Okay, thanks. Next slide, please. I will present an initiative about improving access to tinyML through a global academic network. Next slide, please. So this is a project we're working on with Vijay and Brian and other colleagues, and it's about creating a community of researchers and practitioners in universities focused on, getting access to tinyML education and working on concrete projects. And we do so by having workshops and seminars, especially with a focus on developing countries, having an online forum and an open exchange of projects and lessons and training material. Next slide, please. So right now we have 20 members, which are part of this network, ranging from Guatemala in the west to Kobe Institute of Computing in the east. So there is about 200 students and professors part of the network. Next slide, please. And the first step, as Kate said, is improving education and access to information about tinyML. So we do so by developing material and by using existing material. So we have the edX course, the Coursera course, the material developed by Marcelo Rovai in Portuguese, and we organize a training at the CTP. So all these activities are listed in the website that you can find here. And the final goal is to provide open educational resources. So not only material you can use, but material you can modify and use for your own courses. Next slide, please. Second point is to provide a standard kit in each university, which is part of this network. So the idea is that if you have the same kit, then you can exchange code with other members. You can exchange tutorials and projects as well. So this is what we're going to do in the next months. Next slide, please. And final is having a human network. So we're using Discord for that. We have about 300 members, university students, PhD students, professors, and they're discussing about the solutions and the problem they're facing with tinyML. Next slide, please. So right now, we started the network about 6 months ago. So we had a number of seminars. We had a big workshop with about 200 people in October. And starting next year, we're going to have hands-on activities as well, once we get the Arduino boards from Arduino. And in May and June next year, we're going to have regional workshops for Latin America, Africa, and Asia. We're going to call for new 20 members, so people can apply to be part of this network. We're planning advanced workshops, face-to-face workshops, hopefully, and student competitions. So you find the website on there, tinymledu.org, and you can find all the information on that website. Next slide, please. And I think that's all from my side. I want to thank the Harvard School of Engineering and Applied Sciences, tinyML Foundation, Google, Arduino, Agimpulse, number of partners that helped us in creating this network. And Alessandro, that's all from my side. Thank you.
Thank you, Marco. And I have to apologize to Vijay. I skipped him, so he was supposed to give the introduction to tinyMLedu, but Vijay, the floor is yours.
Awesome. Thank you, Alessandro. Hi, everyone. I'm very excited today to be talking to you about tinyML education. As much of what we've seen, one of the most exciting things that's happening in the space is everybody wants to get their hands on embedded systems because there's a lot of innovation and a lot of good that can come out of what we're doing. However, this begs the fundamental question of how do we actually systematically and efficiently train the next generation of students who can actually bring that change that is important or needed to address many of the concerns. So let's move on to the next one. So the fundamental mission of tinyMLedu, which involves multiple efforts, including what Marco just kind of talked about, is really kind of focused on widening access to applied machine learning by establishing best practices in education. What this means is that we want to bring about equity in the system. Everybody should fundamentally have access to first-class education, especially when it comes to machine learning or AI capabilities. And that's the key goal. And this is a very complex and a long process to achieve. But let me kind of explain how we go about this. The next slide, please. The key thing that we need to do if we want to enable tinyML, as much as we're excited, is really first and foremost thing is we have to train the next generation of students. Now, training this next generation of students means that they actually have to understand rather different intersections between fields. This is not the same as what we've been teaching in the past, where there's something specific like an embedded system or a small hardware device, and you can just focus on that. tinyML is unique. Given the potential it has, we really have to bring together a little bit of machine learning knowledge. We have to bring a little bit about hardware knowledge. We have to bring a little bit of software knowledge. And that means that we have to pull all of these things together. So it is a new area of actually teaching things. And another very important thing, the last point, is that flowchart that I have at the bottom, sorry, on the first part, on the problem statement, is that we actually have to teach people the end-to-end machine learning stack. Often we get excited in saying, oh, look, this amazing thing can tell you if it's a cat or a dog. Well, really, honestly, that model is not the important thing. It's about understanding how you get the data, who controls the data, where does this data come from, what are the characteristics of the data, and then progressively kind of walking them through the entire flow. This is something that is actually not taught in a large number of the machine learning courses that are out there, for instance. And so the question becomes, how do we teach this? There's a fundamental new pedagogical approach that we have to get our head into. Moving on to the next slide. Thank you. So the way we're trying to solve or trying to achieve this solution is basically by building an open access sort of educational material. Now, this can be done by having folks like myself. I'm a faculty member at Harvard. We have made all our tinyML materials publicly accessible thanks to Harvard's support in doing this. But it also needs much more. Right? It's one thing for people like me, for instance, to contribute my little piece and make it open. But we need to bring the entire community together. And that means we have to kind of get people that are interested in disparate areas, which might include, as Marco mentioned, focus on developing countries and their specific needs and their specific example use cases, focusing on K through 12 needs, which Hal will actually get into soon, and then talking about also aspects of STEM education, which Greg Gage will talk about later on. And then not only driving the fundamentals there, but also pushing innovation in the research space. And so we've been creating a lot of different working groups and activities around the space. Next slide, please. One of the key things that we've done in terms of the impact we have achieved so far is we created the tinyML edX course, which is open for all students globally anywhere. And right now it's taken by students over 177 different countries with over 57,000 students who've actually picked up and learned something about tinyML. And thanks to Marco, which you just mentioned, we're now creating a global network within universities instead of just kind of putting material up. And this is really going to be fostering educational outreach at scale. Next slide, please. But there's a lot more to do. Right? This is, as I said, this really kind of rests not on just a handful of people. It really rests on all of us coming together and doing work here. And one of the key things is, like, while there's a lot of material that is out there, it's the important aspect is converting all of that into a sort of a course or a course in a box or a pedagogical sort of an approach, which is different from just giving raw material. Because if you want to really train the next generation of students who understand this and can build the future, then you need to give them systematic aspects. You need to systematically teach them the core components. And so if you're interested, feel free to join us. I've left some information on the slide here. With that said, that's about all I got.
Thank you so much, Vijay. Cool. And we have our next speaker. Olga, if you Perfect. Yeah. Thank you.
Hi, everyone. I'm Hal Speed. I'm a global computer science education advocate. I do work with Robotical, which is a small robot for early learners, Kids Park Education, and also part of the AI for K-12 initiative to provide a curriculum framework for teaching AI in the K-12. And then I also worked with Jonny in the past as part of the Microbit Educational Foundation. Next slide. So as Robert and Vijay have talked about, one of the enablers to really getting AI and machine learning into K-12 for primary and secondary students is to develop this end-to-end pipeline, the tool set that we need to enable the learning to take place. I think many of us here on this call know the importance of connecting hardware and software together. There's a number of existing pieces already on the software side, great tools like Teachable Machine and Lobe and Machine Learning for Kids, Code.org. There's been some work out of Japan to connect Scratch and Teachable Machine to be able to bring a trained model into the Scratch environment. Likewise in China, Mblock has been able to integrate some Teachable Machine, but they fall short of then connecting it and deploying it to hardware and being able to do the inference on the hardware side. You know, Vijay and the team at Harvard and Google in partnership with Arduino have done an outstanding job for adult educators to develop the lessons, the courses, the pipeline using the collabs with Arduino Nano 33, BLE. And so part of the goal of our working group is to bring that level of learning down into the primary and secondary ages for K-12 students. There's other professional tool sets like the Edge Impulse that is then being integrated into something that I really want to highlight from Seed Studio, which is their CodeCraft software. So next slide. So Vincent, in a couple of talks, is going to show you a real live implementation of how he used CodeCraft with robotics. I'm just going to touch a little bit on, this is the real first end-to-end pipeline for K-12 that I'm aware of that takes all the way from the data acquisition to model training, the deployment to a piece of hardware that Seed has called the YO terminal. And then most importantly, it comes with lesson plans and instructions for educators to be able to implement in the classroom. Right now, those include exercises in keyword spotting, using the microphone on the YO terminal, as well as the motion sensor and IMU. And there's other lesson plans under development that will start to address vision with a camera. So part of our working group, the real call to action for the ecosystem is if you're involved in this tool chain, either on the hardware or software side, you know, let's put all the pieces together so that we can build the enabling tool set that then we can provide to educators and course providers that then can start to write AI and machine learning courses for these age groups. Thank you.
Thank you, Hal. Thank you for your presentation. And now we have Greg Gage, CEO of Backyard's Brain.
Hello, I am a neuroscientist, which means I study the brain. I'm interested in how neurons give rise to behaviors. Next slide. I'm going to just talk about the larger problem that we're facing in neuroscience and then a bit more how tinyML can help. But the first part is that 20% of the world will have a neurological disorder, 1 out of 5 people. And how many cures do we have? 0, quite famously, no cures for any neurological disease. Next slide. The other problem is that we're not teaching neuroscience in schools. We don't do it in K-12, barely in undergraduate. You basically have to go to graduate school because neuroscience is kind of deemed too hard. Also, the equipment is quite expensive. And so about a decade ago, I started an organization with a lab mate called Backyard Brains. If you go to the next slide, where we sort of democratize neuroscience by, sort of replacing $40,000 rigs with kind of open source DIY hardware that allows you to record from brains and, do various different types of neuroscience experiments to understand a little bit more not only how to be a neuroscientist, but also a little bit how the brain works. So next slide, I just want to talk about how neuroscience actually works quite well with tinyML. It's every signal that we can record from the brain or from the output to the nervous system is it's an analog signal, one-dimensional, and it's perfect. So I can do a quick demonstration of an electromyogram here. So I'm going to move my arm right now. Sound you're hearing is the output of my motor cortex sending down to my synapsing on my spinal cord, coming out to my muscles. And that can get picked up by sensors. We can stick that sensor into an Arduino. Here's a classic Arduino, just to kind of give you an idea of what you can do with it. So here's like a simple brain machine interface that just uses a Arduino and a servo. But with tinyML, we can go a little bit deeper. And so we're starting to build lesson plans around, integrating neuroscience within tinyML. So the next slide. I'm going to talk briefly about some of the projects that we developed over the past year with lesson plans for teachers. Your eye is actually a dipole. It's got a positive and negative end. And as you move your eye around, if you put electrodes on your eye, you can actually see the swinging of the eye in what's called saccades, or what's more importantly, you can actually see blinks. So these little, less than 100 millisecond, 100 to 150 millisecond blinks, we can detect quite easily with AI. And so we can sort of separate your looking around from when your eyes are closed. And if you go to the next slide, I'll show you what we've developed. We basically did the Nano BLE 33 holder, which is a set of glasses, and we put the camera on there as well. So when the AI detects an eye blink and not a saccade, we can take a picture of what you were looking at when your eyes were closed. So at the end of the day, you can watch a movie of everything you missed when your eyes are closed. It turns out if you live to be 80, you lose about almost 1.5 to 2 years of your life just from your eyes being closed for 150 milliseconds every 6 seconds. So go to the next slide. And so we're doing this with a whole bunch of signals, a lot of things from EEG. This is the electroencephalogram coming from the brain, from the motor cortex. If you want to do some, motor planning type stuff, visual cortex, if you want to look at, these visual readers, if you want to be able to pick a card by staring at a card, if it's flashing at a certain frequency, we can detect that. Stress levels in your autonomic nervous system. We have a student working on a poker bluff detector using EKG recordings in your skin galvanometers. And of course, the EMG can get much more complex if you are using sort of tinyML to help decode that. So next slide. And so my call to action for everyone is if you know people that are using tinyML within STEM fields, for example, in physics or chemistry or geography, I'd be interested in chatting with them because we're starting a working group, tinyML for STEM. We're going to be building some content and some talks around that. And if you're interested in learning more about how tinyML works within neuroscience, we'll be running another summer program with teachers next year throughout the summers. If you interested with that, you can follow us at backyardbrains.com. Thank you so much.
Thank you, Greg. Awesome talk. We now have Brian Plancher.
Yep.
Hi, Brian. Welcome.
Hi. So if we could go to the next slide. I'm Brian. I'm going to talk about a little bit of the outreach work we've been doing as a part of tinyMLedu. And here I'm going to give one example of a program we ran to teach embedded machine learning for the Navajo Nation. This was a collaborative piece of work between Harvard, Google, Navajo Technical University, and Edge Impulse, with special thanks to the TensorFlow Lite micro team and the tinyML Foundation for all their help. We can go to the next slide. But I want to think of this both as an example of this particular program, but also an example of how you might want to think about creating a zero to tinyML hero workshop. In particular, on this one, we were targeting middle and high school students and teachers, but I think there's a bigger question also around how do you provide globally accessible and relevant educational materials on applied machine learning. And as Vijay is saying, this is actually quite challenging and there isn't a lot out there. And both Vijay and I think the answer is through tinyML. So next slide. And I think part of why this is so good is because tinyML helps us actually very quickly go through that whole workflow. We can have students collect data, design and train a model in a very short amount of time, deploy it and actually test it on their own devices, whether that's a true Tiny device or even a proof of concept of what tinyML can do on somebody's phone. Next slide, please. And I think this conceptual learning through hands-on activities gets at a lot of the points that have been said before and allows you to have some quick wins that are really exciting and show students that it is possible to really do this and that they can do this. And so in this program, for example, we started initially because many of these students had no background in artificial intelligence or machine learning. We started with just what is artificial intelligence and machine learning and how could you try to deploy that and use it quickly. So we had them play with Google's Quick Draw application where you can sort of draw little shapes and the machine learning model will guess what it is, or it'll try to auto-complete it. There's another one that does that. And there's a third one where you can actually, the thing translator, you can take a picture and it will tell you what is in there and then translate it to another language. But then we moved on from there to actually machine learning to tinyML, and we used Edge Impulse to train a keyword spotting model. So we had everybody record some data and you could train a custom keyword spotting model. Next slide, please. But as we did this, we wanted to think about making it specific and relevant and exciting to the particular students. So we were tuning the workshop particularly for the Navajo Nation. So for example, when we did the keyword spotting model, we used the word yaate, which is a word in Navajo for like hello and goodbye. And it has a couple other meanings as well. And then we actually had a presentation by Navajo Technical University staff talking about how to use machine learning to spot jewelry, fake jewelry, which is really important industry on the Navajo Nation. And so this was actually a really, really relevant and useful example for them. And a lot of students found this particularly engaging. And while we're thinking about being locally and culturally relevant, we also wanted to focus on responsible AI, as this is tinyML for good. And so we want to think about how do we eliminate bias and how do we make sure that all of these models that we are helping people learn about creating are for good for the future. Next slide, please. And as Vijay and Marco and many others have said, we're open sourcing our materials. We're trying to post all the examples publicly because we want anybody to be able to, one, just reference it later, but two, I think it's actually really important to make sure that if you would like to build a similar workshop, you can start from somewhere and you can have these materials. So next slide. So I think the call to action, wrapping up, I think a bunch of us who are working on these various tinyML EDU efforts is just that I think this is just the beginning. We're just getting started. We've got a lot of really exciting activities going on, and we're trying to broaden participation and access to machine learning education. So if you want to learn more about tinyML, we've got links to a bunch of courses on our website, a bunch of MOOCs and a bunch of other material. If you want to teach tinyML, we have a bunch of example materials. We've got slides, we've got code examples, we've got all the materials from these various workshops, like the one we ran for 4D and this particular one. And if you'd like to help, please let us know. We're always looking for new and exciting ways to improve the future of STEM education. And we think a lot of that is through tinyML. So thank you.
Awesome. Thank you, Brian. Thank you for that talk. And we now have our next speaker, Vincent Koch, Product and Sales Manager at Ubitech Robotics. Hi, Vincent.
Yeah, hi, good day, everyone. I'm Vincent here. And today I will be talking about tinyML for AI robotics and application in education. So basically, the problem statement is that in today's modern world and also with the rapid evolution of technology and the requirement of the Sustainable Development Goal, which is one of it, quality education. So STEAM educator, they got to stay on top of the technology. Means that they need to equip themselves with modern skills and tool set. But however, the case is that most of the STEM educators are not often trained on how to utilize machine learning and tinyML in their lessons. Yeah, next, please. Thanks. So for the tinyML STEAM solution, a big shout out to SIG Studio in enabling tools such as CodeCraft, graphical block-based programming platform on real terminal hardware. That was just released a few months ago. So I have personally tried out this CodeCraft platform, and I think that is amazing experience. And because it gets you started easily with the block-based coding, and actually later on, you will actually generate the text-based coding for you to scale for some other use cases. Next. And for this solution, it has a huge impact where it enables educators to easily create tinyML application project on real terminal hardware and easily can be shared with their students. So these are some of the projects that are done by myself and also the community members using the real terminals and Codecraft. Next, please. So for this session, I would like to talk more about also my project, which is a voice-activated robot car. So in this project, I have two main elements. So which is the AI portion and also have the robotics. So for the AI portion, actually I trained the wake up voice recognition model on the Codecraft. So, and then later on, I generate the text-based coding to scale it in the C programming. And after that, on the robotic side, actually I'm using the robotic kit from UBTech. So this is a robotic kit that is based on the Arduino ecosystem for quick prototyping and can be programmed easily via Arduino IDE. The working principle of this project is fairly straightforward. So you will have the real terminal to do the onboard inferencing to recognize 3 different conditions based on the voice input. So when the confidence of recognizing the word go is greater than 80%, it will then send the command 1, over to the robocar by using UART serial communication. And when the robocar receives the 1, it will then move forward. So the same case happens for the word stop and background noise. So if you want to check more about this project, you can scan the QR code, so which will direct you to the Hester project page. Next. So here's just a simple demo, so you can see that it's actually when I voice up go, then it will just go, and then when I stop, then it will just stop. So it's just a very simple proof of concept to illustrate that the voice activated robocar. Yeah. Next, please. So maybe for some more advanced user, you can actually develop the tinyML project based on the Edge Impulse platform. There are quite a few numbers of fully supported development board that you can go with, such as the ST IoT Discovery Kit and also the NVIDIA Jetson Nano. Next, please. To close out my presentation, here's the call to action. I have compiled a list of useful resources from ebooks to some video courses. So I will also encourage you to join the Six Studio Discord channel to get the latest update and help in regards to tinyML. With that, that is the end of my presentation. Get inspired, make great things happen. Thanks.
Thank you, Vincent. Thank you for that presentation. And we have our last speaker for this section, for the education sector, sorry. It's Parker Zhang, MTS staff, Senior Qualcomm Canada.
Okay.
Hi, Parker.
Thanks. Yeah. Hello, everyone. It's my great honor to introduce this interesting project that we've done this summer. Can you go to the next slide, please? So Smart Bird Feeder is a really fun project done by 9 kids from 5 families in this summer. So due to COVID-19, there was very limited option for summer camp. So, as an machine learning engineer and a father, I was thinking, why not take this opportunity to let kids have a little bit taste of machine learning, or maybe, try to understand what their daddy is doing every day. So after discussing with a few friends and colleagues, 5 families jumped on board, and 1 week machine learning summer camp, a tinyML summer camp opened. So inspired by Google Quora's bird feeder project, so we introduced this real-world problem to kids. That is, squirrels will steal food from most bird feeders and leave nothing for birds. And the kids' mission is to build a smart bird feeder to automatically scare away squirrels. Go to the next slide, please. So kids are really excited on this idea, and on the first 2 days, they started to design and build their bird feeder literally from scratch. Of course, they need to consider many real-world challenges in their design, such as long-standing structures at ordered environment, enough space for tinyML components, and the proper lighting for camera, and weatherproof is also extremely important. Next slide, please. This ended up 6 beautiful bird feeder, all with unique designs. So at that moment, I just felt my years of investment on Lego finally pays back. In the next 2 days, kids were exposed to some AI fundamentals, learned importance of data, and also helped to capture many images for model training. They also learned some basics of digital cameras, the similarity between cameras and their eyes. And on the end of the week, they assembled AI components into their feeders and put everything together in the real-world test. And the kids are really, you can, from the image, you can see they're really proud of their creations. And considering kids' age only range from 5 to 9, the AI model training and the board design are done by parents. And later, we submit this project to Eyes on Edge tinyML Vision Challenge and won the award of honorable mention, which is a truly surprising and fantastic gift for kids in this summer. Go to the next slide, please. So before showing some quick demo video, I would like to summarize that this project is truly a rewarding experience. Also, to echo what Kate mentioned in her keynote, letting young kids play with tinyML is not necessarily to learn programming or fancy robotics, but rather give them a new window, a tool, a tiny antenna to interact and communicate with nature and their surroundings. So on this perspective, tinyML is an easy, accessible, affordable, and amazingly fun way for kids to learn and experience AI. Go to next, please. Maybe next slide. Yeah, so this is the quick video, like close up, showing how this bird feeder works. As you can see on top of the panel is the solar panel that keep charging the batteries. And inside there's the feeder is built on top of the Arduino 9033 BLE. There's a camera attached to watch outside if the bird or squirrel, right? If the squirrel comes to just generate some noise to scare the squirrel away. So that is what we've done. Thank you.
Awesome, thank you, Parker. And we're done with the education piece.
As always, we'd like to thank our sponsors. Without this, it can't be done. So specifically our strategic partners, these are companies that have got involved in tinyML to help steer the direction and set the vision and drive the vision. And we'd love to see more strategic partners come along. We meet once a quarter where we can talk about some of these issues and technologies in a smaller group and come out of those meetings with specific calls to action. So if you'd like to get involved with the tinyML Foundation, and we'll give you more information. So the partners are Aeon Devices, ARM, DeepLight, Edge Impulse, EMSA, Greenwaves Technology, Gravity, HOTG, Imagimob, Latent AI, Maxim, who are now part of Analog Devices, Qualcomm, IXO, Reality AI, Renesas, Rexon, SAP, Seed, Sensimal, Stream Analyze, SynSense, and Sentient. In terms of executive partners, we have various levels of partners and sponsorship. There's more information about this at tinyml.org. But we have ARM, who's been a great supporter since the beginning. Edge Impulse, who is a great solution for all tinyML developers. Qualcomm, again, one of the founding members of tinyML Foundation. And Sentient, and then our platinum partners, DeepLight, Reality AI, Renesas, and our gold partners, Latent AI, Maxim Integrated, now Analog Devices, Seed, Sensimal, SynSense, and our silver partners, Aeon Devices, EMSA, HOTG, Greenwaves, Gravity, Imagimob, IXO, Rexon, SAP, Stream Analyze. So thank you. once again, this has been a fantastic event. I've learned a lot and I've been inspired tremendously. I hope you have. And it's now about rolling our sleeves up and getting down to action and helping the people that have requested help this morning in some of their talks, and showcasing some of their global initiatives that they're working on. I'm sure we can all come together and give a helping hand. And let's all get together and solve some of these global challenges. And if you need more information, just go to tinyml.org.